Dear students, welcome back to my channel. Today I will discuss a new chapter which is very much important, and that chapter is about the matrices. Now, many of you are unknown about this chapter. Okay, so let's start by knowing the definition of matrices and what it looks like actually. Matrices is nothing but a regular rectangular arrangement of numbers in the form of horizontal and vertical lines in an enclosed format. That means it is a regular rectangular arrangement of numbers. That means there are few numbers which are regular, right, which is not in fraction, and also in rectangular pattern in the form of horizontal and vertical lines. Now horizontal line means row and vertical lines mean column. So they are in enclosed format, right. So what it looks like, suppose I am arranging few numbers, random numbers, like this. I am arranging some numbers in rows and columns, okay, and in an enclosed format. So it is a matrix. So what is the use of matrix in mathematics? In the higher disciplines of mathematics, in algebra, geometry, statistics, physics, chemistry and economics, when we have to do some complex sums, to make it much easier, we used to take the help of these matrices, right. Now before starting this chapter, I want to share some of the terms which are very much important and which are very much related to matrices. So let's start with those terms or definition. First of all, each of the number of a matrix is called element, right, and this horizontal line is called the row and the vertical lines, these are called columns, okay. Now the important definition or term is order of matrix. That means how many rows and how many columns are there in a matrix. As you see from this matrix format, there are 3 rows and 3 columns. So it is in the form of 3 by 3. This into, I will not call it into, I will call it 3 by 3 format. And what is the order? 3 by 3 order. Like that, if I write 1 0 minus 1 0, it is in a order of 2 by 2. If I write in 1 minus 2 0 6, it will be 1 by 4. That means first of all we will write the row part and then the column. 4 numbers are in the column and there is 1 row. So 1 by 4. If I write this minus 1, 3, 4, 2, minus 5, 11 matrix, so I will call it 2 by 3. 2 by 3 format. Number of row is 2 and column is 3. So 2 by 3 format. Okay. Now, if I tell you that within this matrix, suppose I am naming it as A equals to minus 1, 3, 4, 2 minus 5, 11. If I tell you that find out the value of A22, that means it is in the second row, second column, that is minus 5. If I tell you that find out A23, that means second row, third column, that is 11. If I tell you to find out A13, that means first row, third column, that is 4. Okay. The next term is equal matrix. Suppose two matrix, one is A, another is B. I am writing those formats. Suppose it is 2, 5, 7 minus 4 and it is 6, 9, 10 minus 12. You can see that both are in a form of 2 by 2. So, I can call them as equal format or equal matrix. Right. Or if it is 2, 5, 7 minus 4 and it is also 2, 5, 7 minus 4, then also we call it equal matrix. But in the case where it is suppose A equals to 2, 3, 0, 7 minus 6, 5 and it is suppose 2, 0, 3, 7 minus 6, 5. You can see that the A22 term here and A12 term and here B12 term are not equal. Here it is 3 and here it is 0. So, they are not equal matrix. Okay. Now, if I tell you that X, Y is one matrix, another matrix is 2 minus 5. If I tell you to find out the value of matrix, then you can say that X is equals to 2 and Y equals to minus 5. Suppose one matrix is like this: 1, minus 2, 7, 6. That means only row is present, there is no column. Okay, so it is called row matrix. Suppose the same thing 1, minus 2, 7 and 6. So it is the column matrix. Right. Another term, square matrix. Suppose it is 2, 3, 4, 6, equal number of row and column. Similarly, suppose 2, 4, 3, 6, 9, 7, 12, minus 3, 4. Number of the rows and number of the columns are equal. So, I can tell you that it is a square matrix, because you know the concept of square where two adjacent sides are equal. Here also number of the row and number of the columns are equal. And here also 2, 4, 3 and 6, 9, 7, 12, minus 3, 4, they are equal. That means number of the column and number of the rows are equal. So, it is a square matrix. Okay. Now, the principal diagonal or diagonal elements. What is this? You know that if I just make a line from my left hand top to the right hand bottom, it will make a diagonal of any square. So, here also diagonal consists of 2 and 6. Okay. Here diagonal consists of 2, 9 and 4. Diagonal elements. Or I can say principal diagonals. Right. Now, zero matrix. What is zero matrix? Zero matrix. It may in a form of this, it may be in the form of this, it also may be in the form of this. That means all the elements within the matrix are 0. It may be 1 by 2, it may be 2 by 2, it may be 2 by 3 itself. Okay. No matter, if all the elements of the matrix are 0, we can call it zero matrix. Okay. Next is the unit matrix. Okay. What is unit matrix? When in a matrix all the diagonal elements are 1, 1. It may be 2 by 2 format, it may be 3 by 3 format. That means if it is 1, 0, 0, 0, 1, 0, 0, 0, 1, you can see the diagonal elements, all the diagonal elements or principal diagonals are 1. So, it is called the unit matrix. Okay. Now, these are few terms of matrix. Okay. Now, let starts with some basic numericals of this chapter. Now, it is the first sum that we will solve. Look at here, there are two matrices in two different sides, left hand side and right hand side. In the left hand side, matrix is of 2 by 2 format, and also in the right hand side the matrix is of 2 by 2 format. In the left hand side the elements are 2x plus 2, y square plus 2, 5, y square minus 5y, and in the right hand side the elements of the matrix are x plus 4, 3y, 5 and minus 6. Okay. Now out of this we have to find value of x and y, right? As from the few definitions we have known that this matrix is equals to this matrix, which is denoted by equals. That means each of the element we can compare itself, right? That means the first element of this matrix is equals to first element of this matrix also, and like the other elements is also comparable with the rest of the elements of the right hand side matrix. So let's start to compare. Okay. Now 2x plus 2 we can write is equals to x plus 4. Y square plus 2 I can write is equals to 3y. 5 is equals to obviously 5, so I am not writing it. Y square minus 5y is equals to minus 6. Okay. Now there are 3 equations. 1, this is 2 and this is 3. From the first equation, just write down 2x plus 2 equals to x plus 4. So from this I can write 2x minus x equals to 4 minus 2, that is x is equals to 2, right? Now I have found the value of x. Now I have to find the value of y. Now look at the two equations. Y square plus 2 equals to 3y. Another is y square minus 5y is equals to minus 6. Now look at the first equation where variables are in both sides, and in this case variables are in a single side. So to compare these two, to find out the value of y, I have to make in a similar way. That means in each of case I have to make variables in the left side and the constant term will be in the right hand side. So first make the change of this particular equation where y square plus 2 is equals to 3y. I can write it in this kind also. Y square minus 3y is equals to minus 2, right? While solving this, I am just subtracting this equation from this equation. Okay. So the signs will be changed. Y square plus y square minus y square will be 0. Minus 5y plus 3y, that will be minus 2y. Minus 6 plus 2 is equals to minus 4. So y will be minus 4 by minus 2, that will be 2. So y is equals to 2. So the value of x equals to 2 and y equals to 2. Okay. So for today just I am concluding this particular video because it is totally new to all of you. So I suggest you to practice it, and we will again do some video. We will solve again some of the numericals of matrix tomorrow, and if you like my video, please tick the like button and please share and subscribe my channel to reach this video to more students of any parts, and we will meet again tomorrow. Till then, bye.